Well, hello, retro computing enthusiasts. Mike here. Welcome back to my channel, and welcome back to Nabu hacking. I've got the Nabu out again, and we're doing some work with it. Now, I've got a whole series of videos on hacking the Nabu. This is a very hackable computer, very easily hackable computer. Um, I forget how many videos I've got. I'll put a link in the upper right to the whole Nabu playlist. But in the past, what I've done is I've written my own monitor program for the Nabu. I've pulled out the original ROMs. I've got basic in ROM. I've got other stuff in ROM. And just hacking the heck out of my Nabu. I've got bank switching on the ROM so I can get more than the original 8K in there. I can get up to 64K of EEPROM in here through bank switching. But I want to take the hardware hacking to another level. I'm breadboarding circuits over here and controlling them from the Nabu. And I'll show you how I do that. It's pretty darn simple. Anybody can do this who's at least been interested in breadboarding some circuits and controlling them from the Nabu. It's so simple. I'll show you why. So here we are looking into the innards of the Nabu. I've got the cover off. And the Nabu conveniently has 4 expansion slots over here. And they're basically 30-pin inline expansion slots. And there were going to be a whole series of cards for the Nabu. They came out with a floppy disk controller card and maybe a couple of other cards, but they were not common. And most people never got them. But the expansion connectors are very, very useful. This is one of the things that makes this such a hackable computer. But these connectors, these expansion connectors, are very convenient. I actually designed an expansion board for the Nabu using some prototyping board here and some inline headers down here to plug in. And I'm planning on building my circuit eventually on one of these. But before I commit it to solder, I wanted to test it out on a breadboard just to make sure I've got all of the issues out of it. Now this is just a simple circuit right here. Basically it's an 8-bit output port. That's all it is. And, but I have grandiose plans for a whole lot more. So I want to prototype it here before I commit it to solder here. So what I've done is I've got a 60-pin ribbon cable here. So basically it's 30 by 2 if you look at the end of it. So I've got it plugged into the number 1 socket over there. And I'm only using half the conductors in the ribbon cable, but that's okay. Not a problem. And then over here at this end of the ribbon cable, I've got some headers, some male headers, dual male headers, stuck in the end of the ribbon cable here. And I can put that right into the breadboard like so. And we've got signals coming out of the Nabu. And we've got this little red LED right here. That tells me we've got power. We've got 5-volt power. So I'm stealing power from the Nabu. I'll put a pin out of the connectors on there if you don't have it. This is coming right out of the Nabu technical specifications. But we can get not only 5 volts, we can get plus and minus 12 volts in ground, of course, data lines, lots of CPU signals, and the lower 4 address line. And a select signal for each of the boards. So there's some internal address decoding done in the Nabu. So each of these slots has 16 dedicated I/O ports decoded for it. So you don't have to do a whole lot of decoding to use the I/O ports on these expansion connectors because you've already decoded down to 16. So you've just got to figure out which one of those 16 you want to use for your project or more. You can use all 16, or you can use 8, or you can use whatever. In fact, if you need more than 16, you don't have to connect another whole cable up to it. You could just connect to the select lines on the other expansion connectors and bring those out. because you've got all the other signals here already. So this is a pretty simple circuit. It's just an 8-bit output port. That's all it is. It's connected up to port address C8, and the number 1 connector over here is decoded as C0 through CF. So I have plans for the lower 8 I/O ports. So I'm using the first in the upper 8 on this one for this this project right here. So let me demonstrate it and show you how well it works. Okay, I moved the camera to try and get the screen and the LEDs on the breadboard in the same field of view. So in my monitor over here, I have a command to read from and write to I/O ports. So if I want to write to an I/O port, 8 of the LEDs on this LED bar are connected to the output port I have set up. So I can do that if I take W in the monitor. It's asking me the port number. Well, that's going to be C8. And now it's asking me for the value. Well, if I put in FF, look at that. All 8 of those LEDs came on down there. And if I put in, let's do that again, W, port number C8, value 00, and the LEDs go out. Right. So that works. What if I put in something else? Right. Port number C8. Let's put in 55 this time. Yeah, half of them light up. So yeah, that works pretty well. I've got a little program that I've loaded into memory, upper memory, above the EEPROM space in RAM, and I'm going to run that next. And it's just a little counter program. And I can run that just by using the G command, which is basically go to, and then putting in an address. It happens to be at 9,000 hex. I'll do that and go. And look at that. We are counting away. So this will count up from 0 to 255 in binary and recycle. And it'll do that endlessly until I reset the machine. I'll give you a look at the schematic for this circuit. It is pretty darn simple. It's 2 ICs, a resistor network, and an LED light bar. The Nabu's doing all the heavy lifting here. There's really not much to this circuit at all. The Nabu's doing most of it. I've got, one IC for address decoding to figure out which of the 16 lines I want to use, and then just a latch to latch the data coming all over the data line from the Nabu. And it is super simple. So I'll give you a look at the schematic. It's a very simple circuit. There's really not much to it. There's a lot of wiring on the breadboard, but it's just connecting everything together. So we've got the cable coming in from the Nabu over here with all of the signals from the computer. And I've got a 74LS138 up here to do my address decoding. A0, 1, 2, and 3 come in. I've also got the select line for the number 1 expansion socket coming in here into one of the enable lines on the 138, and the I/O request line. So when these lines are all low, A3 is high, CSO and I/O request are low, we're selecting port C8. So that's going to be the select line that I'm going to use to latch the data coming in from the data bus, which is again connected to the ribbon cable coming from the Nabu over here. We're going to latch the data down here. Now, some of you may have noticed that this is going to latch on a positive going pulse, not a negative going pulse. And we're providing a negative going pulse here when the address decoder decodes the proper address. Well, how does that work? Well, when I/O request is deasserted, the data on the data bus is still valid. You can see that if you look at the Z80 CPU's timing diagram. So this is going to be deasserted first, and then we'll get a positive going pulse out of the select line, and that will latch the data, which is still valid on the data bus, into the 74LS273 latch here. And then the output is displayed on the LED bar graph. So I've got some 330 ohm dropping resistor network here to prevent from overcurrenting the LEDs, and that's pretty much all there is to this circuit. There is a another LED with a resistor just to show that I've got power coming from it. I did not include it in this circuit. And as I said in the video, I have grandiose plans for this. There's going to be a lot more than this added in the future. This is just a starting point. I need a latch for what I plan on doing. So this is a good way to test that everything is working and that my latch is going to work. So we're starting small, but from this tiny acorn, a big oak is going to grow, trust me. So yes, the Nabu is an incredibly hackable computer. I just, when I got this thing and I opened it up and looked inside, I'm like, holy cow, this thing is just begging to be hacked. It's wide open. You can do whatever you want to with it. And, you know, I am a hardware guy at heart. I just love messing with the hardware, and I am just having a grand old time with the Nabu, with the EEPROM bank switching, and now with this breadboarding. The sky's the limit what you can do with this, and I've got big plans. So I think there's going to be some more videos coming down the line in the future of me hacking my Nabu here, because it's just begging for it. It's just so darn easy to hack. And check out the other videos in the series too. I'll put another link in the description at the bottom of this video if you want to see what else I've done with the Nabu over time. And subscribe to see future videos, because there's going to be more Nabu hacking. There's going to be other stuff. You know, I've still got to work on my TRS-80 Model 1, which needs restoration. I'm always working on my S100 box. And I've got a bunch of other retro computers here, a Morrow Design CPM machine, and well, I'm up to my eyeballs in retro computers. So if you found this video at all interesting, educational, informative, inspirational, get out there and hack your Nabu. If so, give it a like, give it a thumbs up. Subscribe to see future videos, and thanks a lot for watching this one. I'll see you in the next one.